Thank you for tuning in to Innovations Unveiled. I'm Marushi, your host, and I'm joined by Gracie, my co-pilot on this expedition. A special mention to Abdul, our exceptional audio engineer.
Hi everyone, we are both students at Georgia Tech and are excited to discuss the fascinating world of steam engines with you today.
Yeah, so steam engines are a really amazing piece of technology. The symphony of steam with its heat, pressure, and mechanical motion come together in a beautiful way, and have left an enduring mark on the course of human history. It's really crazy and awe-inspiring when you step back and think of how many things have come together to make this invention. Join us as we continue our exploration, uncovering the various types of steam engines, the ingenious minds behind them, and the lasting impact they've had on shaping the world as we know it.
So let's jump right in. How was the steam engine created?
Well, that's an interesting question, and a bit of a loaded one. There were a lot of things that happened before we got to the steam engine. A lot of people start this conversation with their direct predecessor, the steam pump. But I'd like to backtrack some more and consider other early steam technologies which were not as popular and maybe didn't have quite as much of an impact, but I still feel are worth mentioning. Throughout history, humans have always sought ways to harness nature and simplify tasks. An intriguing example takes us back to ancient Greece. Historical records from 1st century AD suggest that the Greeks were early experimenters with steam-driven devices. Hero of Alexandria, a Greek engineer, described a device known as the Aeolipile. This device employed steam to generate rotational motion, which is basically just a fancy way of saying they used steam to make a ball or an orb spin round and round. It was more close to a party trick than something which would be used or had a practical application. Although these ancient experiments lacked true practical applications, they were a remarkable start. Hero's original writings are actually still accessible through the University of Cambridge's digital library in the original Greek.
That's really cool. But how did the Aeolipile influence the steam pump and engine at the beginning of the Renaissance?
Well, that's what I found interesting and why I kind of brought it up, is that the two were created without any interaction. They were completely independent, which just goes to show that humanity has always been fascinated by harnessing steam and nature.
It's crazy to think that Renaissance thinkers and engineers thought they invented the only machine that used steam. However, they were a bit late to the party because Greeks had already beaten them to it.
Yeah, that's technically right, but that brings us back to the point of trying to find practical applications to these technologies, which is a huge component the Greeks were missing.
But Renaissance inventors still had a lot to learn, just like the Greeks before them. During the Renaissance era, the early steam engines were simple machines that were not very effective and used excessive amounts of fossil fuels. The issue of flooding mines brought scientists like Torricelli, as well as Pascal, to local mines in France. This is where they began to use their ideas of steam with atmospheric pressure to influence other Renaissance thinkers such as Thomas Savery, who eventually created the first successful steam engine.
Right, so let's fast forward to the 16th century. That's where two key figures, both coincidentally named Thomas, which is quite funny to me, played pivotal roles in advancing steam power. These men were named Thomas Savery and Thomas Newcomen. You mentioned Thomas Savery earlier. And according to an article by Carla Lyra at the University of Michigan, these innovators introduced a fundamental concept that would shape modern steam turbines. So let's start with Savery and his revolutionary invention, using condensation to create a vacuum.
So when talking about Savery, we talk about the Savery engine, which was created in 1695 and was in use until 1702. Dr. Nuvolari mentions the first defect was the restricted height of operation. The suction lift could raise water only to a height of 20 feet. The second was the high fuel consumption due to the need to recreate steam inside the vessel at each stroke. Even though it was very impractical to use, the Savery engine showed all the possibilities that the steam engine could achieve.
Right, so as we delve deeper into the annals of steam engine history, the narrative continues to unfold into the early 18th century. In 1712, Thomas Newcomen's steam engine, often referred to as the atmospheric engine, saw successful practical application. He had been building and expanding on Savery's concept, dedicating about a decade to refining the pumps, which led to the subject of our podcast today, the modern steam engine.
So, what has not been said that leads us to where we are today?
That's true. We're quite a bit away from modern steam turbines, so while Newcomen's engine was certainly an amazing breakthrough, it still had limitations. It was still inefficient, consumed a vast amount of fuel, operated on a cycle of heating and cooling, which resulted in considerable energy waste. The need for improvement paved the way for further innovations, and the entry of a new name into the steam engine saga, James Watt.
So, leading up to James Watt, the Newcomen engine fixed the height issue and allowed for water to be pumped higher out of mines. Before the Watt engine, cities such as London and Paris started using the Newcomen engine for water supply pumping, especially in the mountainous regions. Scientists and mechanics worked on making the engine cheaper and more economically profitable. However, the main cause of the heightened price was fuel consumption. This was not fixed until 1760 when James Watt invented the Watt engine.
Right, so Watt was a Scottish inventor and engineer, and what he did really played a transformative role. In the 18th century, we're still in the late 18th century, that's where Watt introduced crucial enhancements, including a separate condenser, which significantly increased efficiency, which helped with the fuel consumption. His improvements laid the foundation for the widespread adoption of steam engines, marking a pivotal moment in the history of industrialization.
So, as time went on, the Watt engine was working as it should. However, people were interested in the steam engine and its power and where that could lead them. They started to add cranks to capture the circular momentum, and eventually, scientists and inventors wanted to see how much power the engine could create. This is when Richard Trevithick invented the high-pressure engine. Mathematicians, scientists, and mechanics were all so fascinated by this machine and their inner workings that allowed this machine to house so much power that for the next couple of decades, the only reason for advancements was solely for experiments and scientific trials.
It's really fascinating to see how steam power is a combination of humanity's scientific curiosity and demand for solutions and practical applications of knowledge. We basically come back to the Greeks, where we're just doing it for the sake of doing it and don't really have a practical application. So when did we start to practically use these engines?
Yes, so it wasn't until the 19th century that the steam engine played a bigger role in society. The Industrial Revolution started booming, which caused cities to rise substantially. With a decrease in mine flooding and an increase in metal extractions, buildings and machines were being built in record times. However, the transport of goods across the ocean and rivers was highly inefficient, and there was room for improvement. That is when William Symington in 1802 decided to harness the power of steam engine and add it to a boat. He was a Scottish engineer that invented the Charlotte Dundas, which was the first steamboat. It was not an instant hit, as it took some time. It was nearly 5 years later when the Clermont in the Hudson River popularized the steamboat. This crucial invention allowed for water and inland trade routes to become far more efficient. Goods and ideas were able to travel faster than before, leading to many great inventions and ideas to come about.
And so the cycle of human ingenuity continues. Invention leads to invention. Now let's pause here for a brief message from our sponsor. Now that we've laid the historical groundwork for steam engines, let's dive into the captivating realm of how these marvels of engineering actually work. At its core, a steam engine operates on the principle of converting the energy stored in steam into mechanical work. The process begins with water, typically held in a boiler, being heated to its boiling point. This is where the magic starts to unfold. As the water reaches its boiling point and transitions into steam, an incredible transformation occurs. Steam, with its expansive nature, exerts pressure within the confines of the boiler. The pressure generated by the steam is harnessed to perform work and drive the engine's mechanisms.
Interesting. But what works with the steam to create the suction we've been seen and talked about?
One of the critical components in this intricate dance is the piston. Imagine a cylindrical chamber with a tightly fitting connecting rod inside. When steam is introduced into one side of the piston, its pressure forces the piston to move. This movement is harnessed and translated into mechanical work. Now, to ensure a continuous cycle, the steam needs some kind of exit route, and this is where the concept of condenser comes into play. We mentioned this earlier, but what is a condenser? So, in early steam engines, including those of Thomas Newcomen, The steam was allowed to cool and condense within the cylinder itself. However, James Watt, his improvement was he was introducing a separate condenser. Watt's separate condenser was a game changer. By isolating the condensation process from the main cylinder, he significantly enhanced efficiency. The condensed steam could be more effectively removed, creating a vacuum in the cylinder ready to receive the next charge of steam. This innovation reduced heat loss and allowed for a more continuous and efficient cycle.
Watt also created a new measurement around this time called the horsepower. Even though it wasn't around when the Savary engine was up and running, the Savary engine was estimated to produce 5 to 10 horsepower. This was seen as a tremendous feat. As Watt's first engines were also 5 to 10 horsepower, however, his improvements in designs allowed for some of his engines to reach 100 horsepower or more. Just the repetition and the change in his different designs created a huge jump.
Yeah, that's super cool to see how quickly it evolved. And the rhythmic dance of the steam, pressure, and movement doesn't end there. The reciprocating motion of the piston, often back and forth, can be converted into rotational motion through a mechanism known as a crankshaft. This rotational motion is a key element in driving various industrial machinery, from water pumps to locomotives and factories.
In the early days of the steam engine, this is also seen as thousands of hectares of marshland were drained and reclaimed for agriculture. This increase in arable land allowed for food production to increase substantially, as well as the economic growth in the agricultural sector. Along with farmland, there was also an increase in efficiency seen in machinery pre-industrial revolution. It was estimated that the newer steam-powered machinery doubled or tripled the amount of certain industries compared to the manual labor during this time.
Right, so in the early days of the steam engine, the mechanical energy which was produced from it was primarily used to pump water out of mines, a crucial application, and that really revolutionized mining. But as it advanced, the applications expanded. It propelled ships, it drove trains, and it powered factories. The relentless pursuit of efficiency and power spurred further innovations, leading to the dawn of the Industrial Revolution.
Yes, this can be seen in the early steamships and railways, as they began to improve the speed and efficiency of trade. It is estimated that these two inventions decreased travel times during the Renaissance by 50%. They also allowed for new trade routes to come about to the hard-to-reach regions.
So as steam engine evolved, so did their configurations. From simple single-cylinder engines, we get to more complex compound engines, and engineers continue to refine designs to extract maximum energy from steam. Evolution of valve systems, governing mechanisms, steam expansion processes played integral roles in achieving greater efficiency and power output. There's lots of different innovations which are continuing to happen with the steam engine.
As an engineering student, it's crazy to see the iteration process we are taught about come to life with the different variations of the steam engine. The greater efficiency and power output caused by many people to be replaced by these steam engines. For example, tens of thousands of hand-loom weavers and hand-loom spinners lost their jobs when the steam engine was introduced into the textile mills. As well as hundreds of thousands of manual labor workers on farms lost their jobs when the steam-powered tractor came into use. Throughout history, people have been worried about the newer technologies and advancements taking their jobs, as seen today with artificial intelligence. It is crazy to think that during the Renaissance era and the Industrial era, there were the same worries among workers of those times.
Yeah, it's definitely interesting to see the parallels today with the innovations in the CS sector pertaining to AI. As a CS student myself, I hear lots of conversations about the changing job market. There's differing opinions. Some people are like it's going to replace most CS jobs. Other people are saying it's just a tool. And it's going to lead to more innovation. And it's very similar to the conversations around the Industrial Revolution. It's also important to note that the principles underlying the steam engine are not confined to the past, just like its social impacts are not confined to the past. The concept of harnessing steam to generate power remains relevant in modern contexts, particularly in power plants where steam turbines convert heat into electricity on a grand scale.
As a whole, the steam engine changed millions of lives and is still in use to this day. They caused an exponential increase in the spread of information. They also increased travel, the efficiency of mining, and the efficiency of cities' infrastructure. All the while, they pushed out some workers, miners, and sailors out of their jobs. However, without the creators and inventors, Watt, Newcomen, and Savary, all of these positives and negatives at that time would never have existed. So as we wrap up this episode from Innovations Unveiled, we want to thank you for tuning in and leave you with one question. How would your life be different if the steam engine and steam pump were never invented?
Have a good one, y'all, and we hope to talk to you again soon.
As an engineering student, it is crazy to see the iteration process we are taught about come to life with different variations of the steam engine. This greater efficiency and power output caused many of people to be replaced by these steam engines. For example, tens of thousands of hand-loom weavers and spinners lost their job when the steam engine was introduced into the textile mills, as well as hundreds of thousands of manual labor workers on farms lost their jobs when the steam engine-powered tractor came into use. Throughout history, people have been worried about newer technologies and advancements taking their jobs as seen today with artificial intelligence. It's just crazy to think that during the time of the Renaissance era and the Industrial era, there were the same worries among workers of those times.